right, we're starting on the 1.7, which is the unit 1 of the new semester of geometry for Apex. So let's take a peek at this no vocabulary words. And again, these are supposed to be things we've seen in Math 1, but we're going to kind of do some review since our semester of geometry last year was during COVID. So let's see what things sound familiar and what don't. So in 10 words or fewer, define each of the pairs of the angles. The first one is linear pair, and this is two adjacent angles whose measure adds up to 180. Now, if you want to put in the little degrees there, you can use the insert equation, but I'll just type it. And then vertical angles are a pair of opposite angles formed by intersecting lines. But let's actually draw a picture of these so we have something handy. So the first one, linear pair, imagine that you have a line. Actually, we can get a real line. Hang on. And that there is an angle coming out of the middle of it, kind of like that. So what is the linear pair here? It is this angle here and this angle here. And if you add those two angles up, do you notice how they form the entire straight line or the 180 degrees? So a linear pair would be these two angles that add up. Now the reason it's called a linear pair is because it is on the line. Notice that this is a ray coming out of the middle of the line and they both form a line. There's something else called supplementary angles where it's any two angles that add up to 180. But just keep in mind that for a linear pair, this is on a line. It's these two angles, two adjacent angles, two angles side by side whose measure adds up to 180 degrees. Okay, let's go draw the vertical angles. This one is two intersecting lines. Oops. And your vertical angles are the angles opposite of each other or across. A pair of opposite angles formed by intersecting lines. So I could say that these two angles are vertical. I also can say that these two angles are vertical. So keep that in mind that when you do make two intersecting lines, it actually makes two sets or two pairs of vertical angles. So use the diagram to identify. So here we're using this diagram A, B, C, D, V, and we're going to identify the linear pairs. Now we're about to do a whole bunch of angle names, and they're going to be 3-letter angle names. So I'm going to go into insert equation, and if you look through here, do you see down here there is an angle button? So this is going to become very helpful here in a second. So inserting an equation, we can type angle in now. Okay, so we have it handy. So go ahead and find that angle so you're ready. Now we're going to talk about the linear pairs. I'm first going to go in the order just starting with A. The first angle name, the right or top first quadrant, would be AVD. V being the vertex, you say that letter middle, and AVD describes the 3-letter name of that first quadrant. So here I go, and it would kind of look like this, you guys. This is AVD, right? So let's describe that first one. as angle AVD. I'm going to copy this so I have the angle handy so it can go quicker. All right, AVD, we could say that that is a linear pair with BVD. So notice where that angle comes from the bottom to the middle to the side. And the reason we say that those are two linear pairs is because this angle and this angle form the 180 degrees. So now we're going to go do the next two. The next two would be this angle. Well, we just did that one last, and this one. They form linear pairs. So here I go. We're going to say angle BVD and angle BVC are forming linear pairs. All right, let's go down to the next one. Now we're going to say BVC and CVA. BVC and CVA. And last, we're going to do these two, CVA and AVD. Oh, AVD is already in here. CVA and AVD. Okay, so those are all of our linear pairs that formed making 180. All right, let's go down and find the vertical angles of this image. So again, if I start with AVD, we're now looking for the angle that is across from it. So notice that AVD is across from BVC. And then we're going to do the other two. We're going to say DVB is across from CVA. So DVB is across from CVA. And those are my vertical angles. When two lines intersect, they form four linear pairs and two sets of vertical angles. All the linear pairs and the vertical pairs share the same vertex, that V that's in the middle. Now, what's the vertical angle theorem? Something, again, that we hopefully know from Math 1. Sorry, everybody, my mouse just stopped working. Hang on a sec. All right. Looks like I got it starting to move here. So anyways, the vertical angle theorem is that those angles that are across from each other, those vertical angles, are congruent. What does congruent mean? The same measure. So this is the theorem that we are supposed to have been exposed to in middle school and in Math 1. So let's practice making mental images using vertical angles to solve these problems. I've recreated our same image down here so we can envision it. But so AVC and BVD are vertical angles. So if AVC equals 60 degrees, then what is BVD? And since we know that vertical angles are congruent, we are able to say that BVD equals 60 degrees. Because vertical angles are congruent. And we do write in that reason below. All right, same thing here on number 2. AVC and BVD are vertical angles, and CVB is a linear pair with BVD, and that equals 75. AVC equals 75. So if we know that this side is 75, then we can do linear pair 180 minus 75, and that gives us that the other side is 105. So we know that this guy's 75, this side is 75, this side is 105, and this side is 105. And you might be looking at the picture like, dude, those look like right angles. But we're saying don't just go based on the picture, go based on the information that you're given, and these are the measures of the angles. So it should be kind of at a slant, right? Anyways, we've got this one at 75, and across from it, vertical angles are congruent. We know that linear pair we can subtract to get the missing number, and so the other side is 105 and 105, those vertical angles. So they're asking about CVB. So the measure of that one is 105 based on our image. And how did we get that? We got that from subtracting from 180, and then we knew that it was congruent to the other vertical angle. So it's 105 degrees. Okay, let's talk now about intersecting lines. Intersecting lines are two lines that cross, maybe. Is that what you said? And perpendicular lines are two lines that intersect at right angles. So draw yourself some intersecting lines that are not perpendicular. And then draw yourself some that look perpendicular, that form the right angle. Okay. Line AB is perpendicular to line CD. How are we going to do this in the notation? We're going to say that AB is perpendicular to CD. And how do I say line AB? I put a line across the top with arrows, and I put a line across CD with arrows. I'm going to pause the video here and I'll continue later.